So this is regards to the engineering knowledge motto exam of July 2015, and I will be explaining it. So question 1 was asked, describe the dangers associated with a main engine starting air system, explaining how these dangers are mitigated. So in this question, they want us to explain how these dangers are mitigated and also be able to describe the dangers associated with a main engine starting air system. And B, state with reasons the three causes of an engine failing to fire on fuel after successfully turning on starting air. C, explain how the engine is transferred to local, that is engine side control, in the event of failure of the main engine remote control system. So in regards to the first question which we were asked, which is to describe the dangers associated with a main engine starting air system and their mitigation. So one of the dangers is high pressure air. So now this high pressure air, the starting air system operates at high pressure, which can pose a risk of injury or equipment damage if mishandled. So to mitigate this danger, safety relief valves are installed to prevent overpressure. So in order to mitigate this high pressure air, one needs to be able to use safety relief valves. So now the next dangers associated and how to mitigate it is the air leakage. Air leaks in the starting air system and can lead to reduced starting air pressure, affecting the engine starting performance. So in order to mitigate it, there is regular maintenance and inspections are conducted to identify and repair any leaks promptly. So now the next question answer is combustible air oil mixture. So after we look at high pressure air, which is one of the danger, air leakage is one of the danger, and the other one is combustible air oil mixture. So now the starting air system can accumulate oil mist, which when mixed with air becomes highly flammable. So now proper ventilation and separation systems such as air oil separators and flame arrestors are employed to minimize the risk of fire or explosion. So in regards to combustible air oil mixture, in order to reduce the risk of explosion, one should be able to imbibe the use of air oil separators and flame arrestors. Next, one of the dangers is uncontrolled engine start. Uncontrolled engine start. So inadequate control during engine start up can lead to overspeed conditions or other operational hazards. So one should be able to use safety interlocks, control systems, and proper operating procedures are implemented to ensure a controlled and safe engine start. So now these are the dangers: high pressure air leakage, combustible air oil mixtures, and uncontrolled engine start. So now the next question is B, which is we should be able to state with reasons three causes of an engine failing to fire on fuel after successfully turning over an air on starting air. So now causes of engine failing to fire on fuel after successfully turning over on starting air. So number one, we have fuel supply issue. So fuel supply issue is one of the problems which causes an engine failing to fire on. Next is ignition starting problem. So when the faulty spark plugs and ignition coils are worn out, there's tendency for the ignition system to develop problem. Next is the air fuel ratio imbalance. When the air fuel ratio imbalance is not balanced, it might lead to error for the air fuel to start. Next question is C, which is explain how the engine is transferred to local control in the event of failure. So when there is a failure, the engine is being transferred to local. So now transferring engine to local control in the event of main engine remote control system failure. In the event of main engine remote control system failure, the engine can be transferred to the local control using the following steps. So these are the following steps in order to transfer the engine to local control in the event of the main engine remote control system is at fault. So now the first step is manual intervention. So a qualified personnel should manually switch the control mode from remote control to local control at the engine control panel. So there's a remote control side and there's what, a local control side. So the qualified personnel should be able to switch the control mode from remote control to what, local control. Next step is toward isolation of the remote control. The remote control system is electrically and mechanically isolated to prevent any conflicting signals or commands from affecting the engine's operation. So after manual intervention by qualified personnel by switching it from remote to local, there must be also isolation of the what, remote control. Next is the activation of the local control. So now, activation of the local control. The local control system, which is typically a separate control panel located near the engine, is what, activated. So it must be what, activated. Next is the word verification and adjustment. The personnel verify the engine operational status and make any necessary adjustment to ensure that proper control and monitoring of the engine is what, locally. To transfer to local control allows the engine to continue operating even if the remote control system fails. So the transfer to local control allows the engine to continue operating even if the remote control system fails. That is one of the benefits of what, transferring to what, local. So if the engine system fails, it transfers to the what, local control engine, and ensuring the vessel's proportion of power generation is not what, compromised. That's one of the benefits of transferring to local. Even though there is a system fault, it automatically transfers to the local control system while the vessel is being what, in proportion. So now the next question is questions 2. You say A, state why direct water injection is used on some engines. So now the question is asking us that why do we use direct water injection in what, some engines, and explain how it performs the duty intended. So now direct water injection is used on some engines for several reasons. So now these are the reasons in which direct water injection is what, used on engines. So now number 1 is cooling and temperature control. Direct water injection helps to control the combustion temperature by injecting water directly into the what, combustion chamber. So now by using direct water injection, it helps to control the combustion temperature, right, the heating temperature, by injecting water directly into the what, combustion chamber. The injected water absorb heat during the what, combustion process. So this helps in what, cooling the what, and controlling the what, temperature. Next is emission reduction. So water injection can help reduce what, harmful emissions, particularly nitrogen oxide. The injected water acts as a natural suppressant for what, NO2 NO4 formation by lowering the combustion temperature and inhibiting the formation of nitrogen compounds. So after looking at the first one, which is cooling and temperature control, so the next one is emission reduction. It helps to reduce the emission of nitrogen oxide gases. Next is what, power enhancement. By reducing the peak combustion temperature, water injection enables the engine to operate at what, higher power output. So emission reduction, cooling temperature, and what, power enhancement. Next, in summary, the direct water injection system performs its duty by injecting water in the combustion chamber at the right time and in the what, right quantity. So the direct water injection must be what, done in what, right time and in what, right quantity. The injected water is topically atomized into 5 droplets using high pressure nozzles and what, injectors. So it must be injected by using what, fine droplets using what, high pressure what, nozzles or injector. So now the next question is description of a direct water injection system with the what, aid of a sketch. So now this is a sketch of a direct water injection system. So we have the engine and we have the direct water system in direct water injection system at the middle, and we have the what, air intake. So now air is being absorbed and then taken to the what, direct water injection system and then connected to the what, engine. So now A direct water injection system typically consists of what? The following main component. So we have the water supply, where the water enter. A water reservoir or tank holds the water used for what? Injection. So there is a tank. This is just a sketch, but there is a tank in which the water reservoir is being held. So the water can be sourced from a dedicated onboard water supply system or treated water from other onboard system. So the water can be treated or directly from a different source. Next, we have the water pump. The water pump pressurizes the water to the required pressure for injection. So after we have the water supply, there is a water pump which helps to pressurize the water to the required pressure. So now each water pump has a particular pressure in which it will be working with. It ensures a consistent and controlled flow of water to the injectors. Next is the third question. Third application, high pressure water injectors. So now the high pressure water injectors are responsible for atomizing the water into what? 5 droplets. So after we have the water supply, we have the water pump in which the water will enter into and be pressurized. Then we have a high pressure water injectors. These high pressure injectors are responsible for what? Atomizing the water into what? 5 droplets and injecting them into the what? Combustion chamber. Next part is the what? Control system. The control system regulates the timing and quantity of water injection is needed. So this control system deals with the timing and the quantity that is what? Needed by the system. So we also have the combustion chamber. The combustion chamber is where the water droplets mix with air and fuel during combustion. The injected water absorbs heat, reducing the combustion temperature and controlling the peak temperature within the chamber. So the combustion chamber is where the water pressure mixes with what? Air and fuel. Then we have the direct water injection system. It operates in coordination with the engine's fuel and air supply system. It ensures the precise injection of water into the combustion chamber. So in summary, the direct water injection system helps to coordinate the operation of the engine fuel and air supply system. It ensures the precise injection of water into the combustion chamber and effectively managing the combustion temperatures, reducing emission and enhancing engine performance. So next is the third question, which is, following the failure of the engine monitoring and alarm system, explain the checks that will have to be made and how the engine room will be operated without this system. So following the failure of engine start, so if the engine monitoring and alarm system fails, explain the checks that will have to be made and how this engine room will be operated without this system. So now this is the answer. In the event of the failure of engine monitoring and alarm system, the following checks will need to be made and the engine room will need to be operated without these systems. Visual inspections. Without monitoring system, visual inspections become crucial. So when there is no monitoring system like alarm, visual inspections is very, very important. That is inspections with the eye. The engine room personnel should conduct regular visual checks to observe the condition and performance of various components such as the temperature gauge, the pressure gauge, the fluid levels and moving parts. Any abnormality or deviation from normal operation should be immediately reported and addressed. So the first thing that must be crucial is the visual checks. Next is the manual measurement. So now essential engine parameters such as the temperature and pressure and fluid levels will need to be measured manually using handheld instruments or manual gauge reading. This measurement should be taken at specified intervals or as per the manufacturer recommendation. So next is manual measurements. So there are standard measurements, so the person should be able to measure it. After doing the visual check, you need to check the manual measurement. So the personnel should be trained to perform accurate manual measurement and record the data for future reference and analysis. Next is sound and vibration monitoring. After doing the visual checks and manual measurement, the next step is to do sound and vibration monitoring. Sound and vibration analysis can provide valuable insights into the engine's condition. So when the person checks the sounds and the vibration, it will help in what giving valuable insights into the engine condition. The engine room personnel should listen for unusual sounds, vibrations. If you have been hearing a little vibration, humming sound, and now you're hearing a very high, you should be able to know the irregularities and any abnormal noise or excessive vibration. Next is the operational logs and records. So maintaining detailed operational logs and records becoming even more important in the absence of automated monitoring system. So when there's no automated system, there should be an operational logs and records, right, in which one can be able to go back and check, okay, this what happened at this time, this is the exact measurement, So now the engine room personnel should diligently record operational parameters, maintenance activities, and any observed anomalies. These records will help track the engine's performance and identify what trends and aid in troubleshooting if issues arise. Hence, watch keeping. Next is watch keeping. With monitoring and alarm system offline, the engine room watch keeping responsibilities become more critical, since there is no alarm and sensors to detect all these things. Next, a enhanced watch keeping should be put in place. A qualified personnel should be assigned to monitor engine operations continuously, paying close attention to vital signs, performance, and any potential sign of malfunction. Strict watch keeping routines should be established to ensure prompt response to any developing issue. So a person should be strictly kept to be keeping watch about all these things when the devices are offline. Next is emergency response planning. A robust emergency response planning should be in place to address potential failures or critical situations. This plan should outline the necessary actions, roles and responsibility, and communication procedures to be followed in case of emergency. Next is operating the engine room without the monitoring and alarm system requires heightened vigilance. So when there is no sensors and alarm system, the operating the engine room without the monitoring and alarm system requires heightened vigilance, regular checks, and increased reliance on manual observations. It is essential to restore the monitoring and alarm system as soon as possible to ensure safe and efficient engine operations and to promptly detect any abnormalities or potential failures. So these are the steps one needs to take when there is no monitoring and alarm system. You can use the visual inspection using your eye, the manual measurement, the sound and vibration monitoring, the operational logs and records, enhancing watch keeping, keeping someone there to watch it. Next is emergency response planning, and that is it. So now question 4. With reference to the survey of diesel main propulsion machinery by the Classification Society, A. Explain the term continuous survey of machinery, CSM. B. Explain how classification societies have reduced the need for attendance by the surveyor. C. Describe how a planned maintenance scheme may be used in conjunction with CSM. D. Describe 2 programs that are approved by the Classification Society that physical opening the machinery is not necessary on every occasion. So the first question is explain the term continuous survey of machinery. So now the term continuous survey of machinery is a survey program conducted by classification societies to ensure the ongoing compliance and reliability of machinery on board ships. I come again. Continuous survey of machinery is a survey program conducted by classification societies to ensure the ongoing compliance and reliability of machinery on board ships. So this continuous survey of machinery is like a group of societies who ensure that Machinery that are on ship are what obeying the compliance and are reliable to the expected rules and regulation. It involves regular expectation, assessment and documentation review of the machinery to verify that it meets the required standards and regulation. The CSM focuses on the continuous monitoring and maintenance of the machinery throughout its operational life. The next question, which is explain how classification societies have reduced the need for attendance by the surveyor. Classification societies have implemented various measures to reduce the need for attendance by the surveyor while still maintaining the necessary level of oversight. These measures include 1. Remote monitoring and data collection. So now this system has have reduced attendance by the surveyor by 1. Remote monitoring and data collection. With advancement in technology, classification societies can access real-time data remotely. This allows them to monitor machinery performance and condition from shore-based offices, reducing the need for physical attendance on every occasion. Next is the risk-based assessment. This classification society prioritizes surveys based on risk assessment. They identify critical areas or components that require closer inspection and focus their resources accordingly. The approach allows them to allocate surveyor attendance where it is most needed, optimizing their effort. So in order to reduce the attendance by the surveyor, these have been put in place: remote monitoring and data collection, and next, risk-based assessment. Next is what increased reliance on shipboard personnel. So more shipboard personnel are being relied on. The classification society may delegate certain inspections or maintenance tasks to qualified shipboard personnel under their supervision. This delegation ensures that routine checks and maintenance activities are performed as required without the need for direct surveyors involvement. So now the next question is, describe how a planned maintenance scheme may be used in conjunction with CSM. So a planned maintenance scheme is a proactive approach to managing machinery maintenance and ensuring its continuous reliability. It involves establishing a systematic program. So a systemic program has been put in place in order to prevent preventive maintenance, that is, prevent the machinery from falling or going to fault, preventive maintenance, condition monitoring and schedule inspections. When used in conjunction with CSM, the planned maintenance scheme complements the survey process by ensuring regular maintenance is carried out, reducing the likelihood of unexpected machinery failures or non-compliance issue. The planned maintenance schemes can provide the records of maintenance activities, performance data and monitoring results, which can be reviewed by the classification society during CSM surveys. This helps demonstrate that the machinery is being properly maintained, and it facilitates the evaluation of machinery condition and compliance with relevant rules and regulations. So that is all about the planned maintenance scheme on conjunction with CSM. They carried out proactive maintenance, such as systematic program for proactive preventive maintenance, condition monitoring and schedule inspections. The next question is question D, which is describe 2 programs that are approved by the classification societies so that physical opening the machinery is not necessary on every occasion. So now these 2 societies are: 1. Condition monitoring programs. These programs involve the use of advanced monitoring techniques such as vibration analysis, oil analysis, thermography to assess the condition and performance of machinery components. By analyzing data collected through these techniques, classification society can evaluate the machinery conditions without the need for physical opening. So the first one, as we have looked at, is condition monitoring program. This is use of vibration analysis, oil analysis, thermography, you know. Next is the use of the computer aided design system, CAD. The CAD system enable the creation and maintenance of digital models and documentation for machinery installation. These models are designed to provide a comprehensive representation of the machinery and its component. By reviewing the CAD models and associated documentation, classification society can assess design, construction, and configuration of the machinery without physical opening it. The next question is question 5a. Describe with the aid of a sketch a waste heat recovery system for electrical generation using main engine exhaust gas in combined gas/steam turbine system. B. Describe the operation of the waste heat recovery system described in part A while the associated main engine is running. So to describe with the aid of sketch a waste heat recovery system for electrical generation, you can see it in this diagram. So waste heat recovery system for electrical generation using main engine exhaust gas is combined gas/steam turbine system. So a waste heat recovery system is combined, that is, this waste heat recovery system is combined with both gas/steam turbine system. Utilizes the exhaust gas from the main engine to generate electrical power. Here's a description along with a sketch of the system. So this is a generator. We have the inlet air, we have the fuel, we have the gas turbine, and we have the combustor. So now from the combustor and the gas turbine, it is now passed through the heat recovery steam system. So now this is then passed to the generator, then to the steam turbine, then to the condenser, and then to the pump, and then to the stack. So this process continues. The waste heat recovery system consists of the following components: the main engine exhaust gas boilers. The main engine exhaust gas is directed to the exhaust gas boiler. This boiler is designed to extract heat from the high temperature exhaust gas. Next is the heat recovery steam generator. This heat recovery steam generator, as you can see on the diagram, the extracted heat is used to generate steam in the heat recovery steam generator. This heat recovery steam generator consists of heat transfer surfaces such as tubes or coils where heat is transferred from the exhaust gas to the water, producing high pressure steam. That's where you can see the pump in the diagram. Next, the steam turbine or the gas turbine. The high pressure steam produced by the heat recovery steam generator is fed to the steam turbine. The steam expands in the turbine and causing the turbine rotor to rotate. Then we have the electrical generator. The rotational energy from the steam turbine is transferred into the electrical generator where it is converted to electrical power. The next question is question B, which is describe the operation of the waste heat recovery system described in part A while the associated main engine is running. So they want us to describe the operation of the waste heat recovery system when the system is still running. So during operation of the waste heat recovery system, the main engine exhaust gas is utilized to produce electrical power through the following step. So we have the exhaust gas flowing. The exhaust gas generated by the main engine is directed to the exhaust gas boiler. The flow of exhaust gas is controlled by the dampers or the valve. Next is the heat extraction. After the heat is being extracted, then we have the steam generation. The high temperature water absorbs heat from the exhaust gas and converts it into high pressure steam. Next is the steam expansion. The high pressure steam flows into the steam turbine where it expands and produces mechanical energy. This expansion of steam causes the turbine rotor to rotate. And next is the electricity generation. The rotational energy from the steam turbine is transferred to the electrical generator. The generator converts this mechanical energy to electrical power. So this is the process for it when it's being the engine is running. So the first thing, exhaust gas flow, then the heat extraction. Heat is extracted, then the steam generation. when steam is generated, then the steam is expanded, and then that heat that is expanded is now moved to the turbine, which what generate what electrical current. Then we have the power generation, which is the final step. The generated electrical power is distributed to various electrical consumers on the what ship, providing electricity for propulsion, auxiliary system, lighting, and other what electrical loads. So the next question is question 6, which is what, with reference to slow speed diesel engines, explain why electricity driven scavenge air blowers are fitted to engines even though turbochargers are fitted. B. Describe how a turbocharger may be disabled to allow for operation of the main engine in the event of failures of the turbo rotor. C. Describe the procedure for operating an engine in the event of a turbocharger not being operational. So with reference to low speed diesel engines, we have A, which is explain why electrical driven scavenge air blowers are fitted to the engine even though turbochargers are fitted. So they're asking us, why do they use air blowers that are fitted to the engine even though there is what turbochargers are there? So with reference to low speed diesel engines, electrically driven scavenge air blowers are fitted to engines even though turbochargers are also present for several reasons. One is what, redundancy and reliability. Electrical driven scavenge air blowers provide an additional source of scavenge air to the what engine cylinders. So it provides an additional source of scavenge air to the what engine cylinders. In the event of a turbocharger failure, the electrical blowers ensure what continuous air supply for what proper combustion and engine operation. Next is what, low speed operation. So after redundancy and reliability, the next one is low speed operation. So low speed diesel engine operate at various speeds, including extremely low speed during maneuvering or idling. At such low speed, the turbochargers may not provide sufficient air pressure for what effective scavenging. Are we together? So that's why we use the electric blowers even though we have the turbochargers, because there are certain times that at such low speed the turbochargers may not provide sufficient air pressure. That's why one needs the what electric blower supplements. Next is load variation. The electric blowers offer greater flexibility, so the electric blowers are more flexible than the turbochargers. Next question is B, which is describe how a turbocharger may be disabled to allow for operation of the main engine in the event of failure of the turbocharger rotor. So they want us in this case to describe how a turbocharger may be disabled to allow for operation of the main engine. So they want us to disable, to be able to disable the turbocharger in order to allow the main engine to operate. So in the event of a turbocharger rotor failure, the turbocharger can be disabled to allow for the continued operation of the main engine. Here is a description of how this can be done. So there are steps. There is 4 steps on which the turbocharger can be disabled. First one is shutdown. The main engine is shut down to ensure safety and prevent any further damage caused by the turbocharger failure. Are we together? Next, the turbocharger is isolated from the engine intake and exhaust system. So when you shut down, you isolate the turbocharger. Next is the alternate air supply. An alternate air supply, such as the electrical driven scavenge air blowers or auxiliary blowers, is activated. So alternate air, which is electrically driven from the scavenge air blowers or auxiliary blowers, is activated. Next, the engine is restarted. So when the alternate air that is driven by electrical, such as the scavenge air and the auxiliary blowers, is activated, then the engine is restarted. Once the alternate air supply is established, the main engine can be restarted and normal operations can be resumed. So the first thing, you need to shut down, isolate the turbocharger, use alternate supply, which are being driven by electrically by scavenged air and auxiliary blowers, then the engine is being restarted. The next question, which is C, is describe the procedure for operating an engine in the event of a turbocharger not being operational. Now, when a turbocharger is not working, they want us to describe the procedure for operating an engine in that event. So in that event, when the turbocharger is not working, the steps you need to do is to shut down. If the turbocharger fails during engine operation, the main engine is shut down to prevent any potential damage. Next is turbocharger inspection. The turbocharger is inspected by qualified personnel to determine the cause of the failure and the feasibility of repair or replacement. If immediate repair is not possible, steps are taken to bypass the turbocharger temporarily. Bypass procedure. So now these are the steps in order to bypass the procedure. The turbocharger is bypassed by what? One, isolating it from the engine intake and exhaust system. So it must be isolated from the engine intake and the exhaust system, because if it is not isolated, it's tendency that it might lead to spark and might cause fire outbreak. This may involve closing valves or dampers to block the airflow through the turbocharger. So you can block the valves in which that accept airflow into the turbocharger. Then you use the alternate air supply that we have spoken, such as the electric blowers or auxiliary blowers. Then engine is restarted, and by this you can bypass it. Number 7, with reference to diesel engine lubricating oil and distillate fuel oil. A, describe the causes and effect of microbial attack. B, explain how microbial attack may be detected. C, describe how an oil system may be returned to service the following microbial attack. So the first one is they want us to describe the cause and effect of microbial attack with reference to diesel engine lubricating oil. So we have lubricating oil, and there's tendency there might be microbial attack. So now, causes and effect of microbial attack on diesel engine lubricating oil and distillate fuel oil. So now, microbial attack, also known as microbiological contamination, can occur in diesel engine lubricating oil and distillate fuel oil. It is caused by the presence of microorganisms such as bacteria, fungi, and yeast. These microorganisms can enter the system through external contamination or through the air and water present in the engine environment. So through water and through air, these bacteria and fungi and yeast, which causes microbial attack, enter into the fuel or the diesel. The effect of microbial attack includes sludge formation. So when there is microbial attack, there is a lot of effect of microbial attacks, which are sludge formation. The microorganism can multiply and form colonies. So when we talk about sludge formation, this microorganism can multiply, give birth and form a colonies in the oil/fuel, resulting in the formation of sludge. The sludge can clog filters, screens, and passages, leading to reduced oil/fuel flow and poor lubrication and fuel delivery issues. So that is one of the example cause of microbial attack. It causes sludge formation, that is making the microorganism to give birth to a lot of colonies. Next is acid formation. So microorganisms produce acid, that means some these microorganisms produce acid. So they are produced acidic byproducts, and they can metabolize organic matter in the oil/fuel. These acids can lead to corrosion of engine components, including cylinder liners, bearings, and fuel system components. Next is filter plunging. Microbial growth can create a slimy biomass that accumulates on filters, leading to their clogging and reduced filtration efficiency. So instead of the filter to be working well, because of this microbial growth, it might be able to block and reduce the filtering effect. Next is degraded fuel quality. Because of this microbial attack on this lubricating oil, the fuel quality is what degraded. So microbial contamination can cause fuel degradation, resulting in decrease in fuel stability and increase deposit in the combustion chamber. This can lead to issues such as faulty injection, reduced engine efficiency, and also increase what emissions. The next question is describe how microbial attack can be what detected. So this can be detected by basically 3 steps. One is visual inspection. Visual examination of the oil fuel can be reveal signs of microbial growth such as sludge formation, sedimentation, or discoloration. Next is the microscopic analysis. So small samples of this oil residue can be taken and be tested, include for bacteria and fungi and yeast. Next is what microbial testing. Specialized microbiological testing can be performed by laboratories to determine the presence and types of microorganisms in the word fuel. So the first one is visual inspection, the next one is microscopic analysis, and the next one is microbiological testing. The next question is C, which is describe how an oil system may be returned to service following microbial attack. So they want us to, after microorganisms have attacked the oil and it has been spoiled, they want us to see if it's possible that this oil that has been attacked can be still be used effectively. So returning an oil system to service following microbial attack. To return an oil system to service after microbial attack, the following steps are typically taken. So the first step is what contamination identification. The type and severity of the microbial contamination are determined through what testing analysis. So first of all, one should be able to what identify what type of microorganism is affecting the oil. This can help in what selecting the appropriate treatment and what prevention method. So if you notice it's bacteria, a bacterial preventive method can be used, or a fungi can be used, or a yeast can be used. Next is system cleaning. The oil system is thoroughly cleaned to remove the existing microbial colonies and sludge. So you can do system cleaning. Next is what biocide treatment. So now these biocide treatments are added to oils like fuel system to eliminate any remaining microorganisms. So this biocides treatment helps to kind of cleanse the system. It helps to eliminate any remaining microorganisms and prevent their growth in the future. The selection and application of this biocide should be done according to the manufacturer instructions and industry based practices. Next is what system flushing and replacement. After the biocide treatment, the system is flushed to remove any residual contaminant and cleaning agents. So the system is washed. The lubricating oil fuel is then replaced with fresh and uncontaminated oil/fuel. Next, we can use preventive measures to minimize the risks of future microbial attack. Preventive measures are implemented. This may include regular monitoring of oil. So by regular monitoring of this oil, you can prevent the issue of microbial attack on fuel or diesel. Maintaining proper storage condition, implementing the fuel and oil treatment programs, and conducting periodic inspections and testing to detect early signs of contamination. So it's also important to consult the engine and oil fuel manufacturer guidelines and seek advice from experts in the case of microbial attacks. So in regards to using the system after microbial attack, you can do contamination identification, system cleaning, biocide treatment, system flushing and replacement. Preventive measures can also play a very vital role. So question 8 is, with reference to the use of HFO, which is heavy fuel oil, in marine diesel engines, they want us to state with reasons the difficulties each of the following fuel properties may cause. So we have density, viscosity, sulfur, catalytic fins, and B, explain what system adjustment are required when these properties change. So now, with reference to the use of the heavy fuel oil in marine diesel engines, difficulties caused by fuel properties, so we'll be looking at density. So we want to state the reason and the difficulties of each of the following fuel properties may what cause in a what heavy fuel oil in marine diesel engines. So density, the density of heavy fuel oil can affect the engine performance and operations. Higher density fuel contain more energy per unit volume, but they can pose challenges such as what increased fuel consumption. So when there is high density, there's what an increase in fuel consumption, and higher density fuel requires a larger volume to generate the same amount of what energy. So this is one of the difficulties. Next is pumpability issue. So if the density is too high, the heavy fuel oil may become more viscous. So that means it will be very difficult for this heavy fuel oil to flow through the pipe, leading to what pumpability issues. This can result in fuel starvation, reduced fuel automation, and incomplete combustion. Next is viscosity. Viscosity refers to the thickness or resistance to the flow of the fuel. So when the flow there's a resistance to the flow, it's not flowing easily, that's when it's what viscosity. So now the viscosity of heavy fuel oil can influence the following: atomization and combustion. So higher viscosity fuels have poor atomization characteristics, leading to large droplet size during fuel injection. This can result in incomplete combustion. So when there is high viscosity, there's also poor combustion. Next is what fuel system operation. Viscosity can also affect fuel system operation. So excessive viscosity can pose challenges in fuel handling and injection system. It may require higher fuel pressures or preheating to achieve proper atomization. So fuel system operation. So in order to solve this problem, one has to preheat so that the viscosity level can reduce. Next is sulfur. The sulfur content in heavy fuel oil has significant implications for engine operations and environmental compliance, such as one of the implications are the difficulties of using sulfur as content is emissions. Higher sulfur content in fuel leads to increased sulfur dioxide emissions, and these emissions contribute to air pollution and acid rain, and is one of the major pollutants which causes global warming. Next is corrosion and deposit. Sulfur in the fuel can contribute to the formation of corrosive acids, right, such as sulfuric acid, which may lead to corrosion and rusting of metal components. And the next one is catalytic fins. So catalytic fins are small particles of abrasive materials that can be present in heavy fuel oil as a result of the refining process. So there might be some catalytic fins, and these catalytic fins can cause some issues, which are engine wear. So these catalytic fins can damage engine components. Next, it can filter plugging. Catalytic fins can clog fuel filters, reducing their effectiveness and leading to fuel starvation. So this filter plugging, these catalytic fins can hang around the filter and may lead to the filter not working well. The next question is B, in regards to system adjustment, which is explain what system adjustments are required when these properties change. So when fuel properties such as density and viscosity and sulfur content or catalytic fins change, the following system adjustments may be required. So fuel heating, so the fuel must be heated in regards to the density, viscosity, sulfur, or the catalytic fin change. Next is fuel filtration. Proper fuel filtration needs to be taken. Next is injection timing and pressure. This deals with adjustment to the injection timing and pressure may be necessary to optimize the combustion and account for changes in the fuel properties. This helps maintain proper fuel atomization, combustion efficiency, and engine performance. Lubrication of oil quality. So a good lubrication when using heavy fuel oil with higher sulfur content, the lubrication oil should be what monitored and changed more frequently. So the lubrication oil should be what changed more frequently. The exhaust gas treatment. So this exhaust gas can be what treated. The installation of exhaust gas cleaning systems such as what scrubbers may require to what reduce what sulfur oxide, so SO2, SO4 emissions, and comply with what environmental standard. Next question is outline the probable events leading to a crankcase explosion, describing the effects and the hazard. So the question is asking us that we should outline or list, events that may lead to a crankcase explosion. So when there's a crankcase that is being exploded, what are the events that lead to that crankcase what exploding? And we should be able to describe the effects and the hazard. Then the next question, as a chief engineer officer, state the standing orders regarding the activation of the oil mist detectors. So in regards to the first one, the probable event leading to the crankcase explosion are as follows. So a crankcase explosion can occur due to a combination of factors. So for a crankcase to be exploded, there are basically 5 events that may lead to it, or more than 5 that may lead to it exploding. So we have the ignition source. So an ignition source such as a hot surface or an electric spark enter the crankcase. So when there is an hot surface, when the surface is very hot and there is an electric spark, this thing can enter the crankcase. Next is the accumulation of flammable gases. So flammable gases such as fuel vapors or burned hydrocarbons can accumulate in the crankcase. So the first one, which is one of the cases, electrical spark or hot surface when the surface is very hot. Next is the accumulation of flammable gas such as hydrocarbons, which accumulates in the crankcase. Next is oxygen presence. So sufficient oxygen is available in the crankcase for combustion. For combustion to take place, there must be sufficient oxygen. And if there is sufficient oxygen, that means there's tendency for combustion to occur in the crankcase. Next is the ignition of flammable mixtures. So the ignition sources ignite the flammable gases present in the crankcase. So when there are these flammable gases mixtures mixed together, there's tendency which may result towards explosion. Next is rapid combustion. The ignition leads to a rapid combustion process, generating a high pressure explosion within the crankcase. So the process in which this explosion takes is very rapid because of the high pressure. So when there's high pressure, this explosion tends to explode more faster. So now, effects and hazards of a crankcase explosion. So when there is a crankcase explosion, there is definitely an effect, and this effect includes structural damage. This explosion can cause severe damage to the crankcase. Next, there might be personal injuries. It can lead to death and injuries of the workers. It might lead to fire outbreak, destruction of properties, destruction of operation, destruction of electrical equipment, high expensive equipment. So now the next question is B, which is, as a chief engineer officer, state the standing orders regarding the activation of the oil mist detector. So now the study orders regarding the activation of oil mist detectors are as follows. As the chief engineer officer, the standing orders regarding the activation of the oil mist detector should be taken into effect. 1. Immediate response. Upon activation of the oil mist detector, all personnel should respond promptly and take the situation seriously. Next is alarm acknowledgement. The designated personnel should acknowledge the alarm and initiate the necessary actions. Thirdly, investigation. The engineering team should conduct a thorough investigation to determine the source and extent of the oil mist or aerosol present. Next is shutdown procedures. If the concentration of the oil mist is deemed hazardous, the engine should be shut down following the appropriate shutdown procedures. So there must be an immediate response, there must be acknowledgement of the alarm, there must be investigation, there should be what shutdown of procedures, there should be what ventilation. Adequate ventilation should be what established to remove oil mist or aerosol from the affected area and prevent further accumulation. Next is what safety precaution. Personnel should follow safety protocols, including the use of personal protective equipment (PPE) to minimize the risk of injury or explosion. Next is reporting and communication. The incident should be what reported to the relevant authorities and communicated to the ship command and relevant personnel for further guidance and action. So in the case of oil mist detector, that means a gas is being opened and one is passive in it, there should be an immediate response. Alarm system, the alarm system should be on. Next, investigation, there should be a shutdown of the procedures. Ventilation, the windows should be open. Safety precautions, people should be able to wear their personal protective wear such as helmet, boots, overall. Next should be reporting and communication to the necessary offices, and it is essential to comply with the company specific procedures and regulatory requirements regarding the activation of the oil mist detector and the subsequent response to ensure the safety of the personnel and the prevention of potential accident or machinery failures. So this is regards to the engineering knowledge motto for 2015 July. Thank you.